This is the third in the series on the Control101 MATLAB toolbox, which focuses on simulink. And here we're going to look at some simple case studies. The community then has agreed on an outline structure for a Control101 course. And it was also thought that MATLAB was quite a convenient environment for supporting such a course because of the MATLAB power for visualization, supporting number crunching, and so on. However, in particular, now we're going to look at simulink, and this particular video is going to focus on the use of simulink for some specific case studies. So why are we using simulink? A quick reminder. So simulink allows you to build models using blocks and arrows and connections, and this is more intuitive for many and easy to follow. It also allows easy conclusion of varied and important components, nonlinearity, and so on, and you will see that as this video progresses. However, there is a warning that simulink files are not always backwardly compatible, so while some might work, others might not, unless you have a recent version of MATLAB. The previous videos then introduced users to some very simple simulink examples and showed how you could access some of the block settings, run simulink files from a MATLAB script, enter the required parameter values automatically into the simulink blocks, and so forth. Now we want to focus on some more interesting case studies to illustrate the power and potential of simulink, albeit much more complicated examples are clearly beyond the remit of Control101. Now this video is going to cover 5 case studies. Each case study has got a separate simulink file and a MATLAB live script for managing the parameter definitions and the plotting. The live script also includes explanation of the engineering scenario, and thus that's the best place to start. So if you type help Control101, then you'll see you get something like as shown in the window here, and specifically you'll see, for example, the hydraulic system. If you press that link, then it will open the live script which allows you to run the hydraulic system and so on. So you see the 5 examples there. Let's do a live demonstration then. So I've got the live scripts already open, so let's bring that across. And here you can see I've got the car suspension one. So if I go to the top, you'll see there's some general discussion as always, a bit of preamble, and then you'll see there's a bit of discussion of what's the modelling that's going on, what's the scenario, because you can do that in live scripts. And then you'll see here's the simulink file which is going to be used. You'll see the name of the simulink file here. Okay, car suspension underscore Control101. So if you'd like to, you can open that. So if I, for example, copy that, and then what I'm going to do is bring the MATLAB window across so you can see. I could go here, open, and then what you'll find is that file opens. There it is. I'm going to move it back out the way, but just so you can see, it's very, very easy to open the files if you want. Everything you need is in this live script. Specifically here, we're now going to analyze this particular case study. So you can see what I've done using the code snippets you can use within the live script is I've defined all the parameters that the simulink file needs, and then I've run the simulation here, and then I've produced a plot. And then you can see the plots appeared on the right hand side. And then I can change the scenario slightly. I can say, oh well, here you can see I've changed the values slightly. So I've changed the values, I've got a slightly different plot. I've changed the values a bit more here, I've got a slightly different plot. And then you see down here in section 2.4, I've actually overlaid different scenarios so you can compare and contrast. So what you'll see, there's a case study on car suspension, and clearly the idea is not that I go through it slowly in this video, but just point you to it and you can read it in your own time. So there's a heating system one. So if we open the heating system one, okay, again you can see here's the preamble going through some of the modelling assumptions and what's going on, a bit on PI compensation, and then you can see here is the simulink model. Now this is a bit of an odd one, because essentially it's got 3 block diagrams running in parallel, and those 3 block diagrams have got subtly different assumptions. If you look carefully, you'll see, I don't know if this will allow me to write on it, but you see, if you look at these bits here, you'll see that there's subtly different assumptions being made, and then all the results are overlaid, and you can see what's going on here. Okay, and again, if you want the code to run it, you can see it's all down here at the bottom. What about the hydraulic system? Oh, I'm going to now need to get rid of all of those. So there we go. So hydraulic system, again, you'll see discussion of the modelling assumptions, a bit of a picture. This is what's going on. Tanks in series, tanks in parallel. Okay. Again, you've got your simulink diagram. Okay. Different simulink diagrams. And down here, the simulation. You see, let's put the data in there, run the simulation here. Tanks in parallel, data here, simulation down here. Okay, submersible, slightly different example. You can see here we've got an underwater vehicle or a submersible, and you'll see all the sort of modelling equations are down here, and you'll see there's the simulink model, which again you can open if you want to, and here you can see the command to open it. So I'm not going to do it, but obviously it's very easy to do. And again, you see define the parameters here, run the simulation, produce some plots. What's the impact of putting in a non-linear component? You can see this section's adding a non-linear component, and again you can look and you see the difference is actually very minor, quite difficult to see. And the position control system, you can see there's the position control system diagram, and there's reduced to a simple block diagram that we can put into Simulink. And again, we can run the files here. Now, I'm deliberately not going through these slowly because that's something that you need to do in your own time. And the purpose of this video is just to highlight all the information is there, all the code is there, so you can open the files, you can read these manuals slowly, go through the code slowly, open the Simulink files if you want to, see where these parameters are being used, change the settings, and so forth. So, we've demonstrated how to run and use the Simulink case studies in the Control101 toolbox, and for convenience we've used livescripts to manage the data entry and the coding, the simulation, the plotting, and so on. But clearly you can copy those bits of code and use them separately if you wish.